Got an old power supply like this, no digital readout, not even volts. Got a cheaper option for you before you go spend 600 bucks on a new power supply. This guy right here. You can get a little digital multimeter, can give you all those readings, and they're generally between 40 and 50 bucks for one that we would use. You could go crazy and spend a lot more, but you could go cheaper and you won't get as many readings. Make sure you get one that reads duty, hertz, and amps, most importantly. I'm going to kind of walk you through how I use this tool to hopefully help you step up your tuning game. So this is a basic multimeter. Not the cheapest junk, just a mid-range one, about 40 to 50 bucks online. It can read duty, hertz, amps, and ohms, and test continuity on rotaries. Pretty important tool to have in your toolbox. So the first reading we'll use to tune our tattoo machine is the hertz, which is the speed of cycles per second. We can find this by turning our dial to the hertz setting, and it'll display the hertz here, and it'll also display the duty cycle here. We press this hold button, it'll lock our numbers so we can stop touching the machine with these probes. So we can see here we got a reading. I'm not sure if you can see this. This machine is running at 127 Hertz and it has a duty cycle of 65%. On snappier liners, that's usually about as high as I'll go, maybe 68%. But generally you'll find most machines run between 45 and 65. As far as speed goes, that's really just a preference number. If you already have a machine that you're trying to tune up, it's nice to have a reference number to go by. But this is a really easy way to figure it out when your power supply is blind like this, just for tuning. As always, just pay attention to how your machine feels. Take note of what you like and what you don't like. If you're finding it's too soft, you may notice a higher duty may help with that. But if you go too high, you'll get a lot of chatter and maybe excess heat. So the next thing we'll test here is the ohms. And we're just moving over one more spot to the ohm symbol there. And to test this, generally you'd want to do it on the solder lugs or on the bare wire, but I'm just going to do it with the binder here. That might add a little resistance and change the number a little bit, but at least give us an idea of what's on the machine. Sometimes it can be a little crazy trying to read this guy. So we can see here this machine is reading about 2 ohms. Generally, a 6-wrap coil is about 1 ohm per coil. So you add the two together and we get 2 ohms. Why would you want to know this? Just if you're curious what size coil is on your machine, if you need to go ahead and replace them, or if you just like the way that setup runs. Another reason is the test coils that you have laying around. The only way to really figure out how big this giant coil would be is either guessing or unwrapping it to see how many layers on it. I can, alternatively, just test this coil, putting 1 lead to each wire. If it says OL like that, it means there's a short in the coil. So I got these wires for the coils wrapped around the leads here. I did scrape them just to test them. As you can see, this looks like it might be a 10-wrap coil, but from testing it, it's coming out at a 1 ohm coil because of the cotton. Kind of changes up the spacing on the coil. So we know that this would run similar to a 6-wrap coil, though it might create some extra heat with all that space in there. Pretty neat trick to have. So here's another set of coils, mystery coils on my bench. They look like 8-wrap coils. They have T-top cores, already soldered. In this case, I would just hook this up to each solder lug. And I should get an ohm reading for this set. You see there, I'm coming out around 2.5 ohms, which if we do the math right, usually an 8-wrap coil would be about 1.2 ohms each, making a 2.4 to 2.5 ohm set. So we know this is good to go for a nice shader or something. But no more guessing, looking at the width of the coil. We can actually test it to find out what it is exactly. Okay, the next thing we want to test is the amps. It's a little bit tricky on these things. We got to run it in line to get a proper amp readout. And so we just go all the way over to the amp symbol, and we have to move this red power port over to the 10 amp port. Now in order to get a reading here, I'm just going to hook the negative up to the machine, the positive, the negative multimeter port to the binder, and just complete the circuit this way. So you can see here we're reading 0.5 of an amp. It's important not to do this too long with this meter. It's not meant to be hooked up permanently to an amp draw like that. It would probably fry it, but it is good for a quick reading. Now it is important that your amps, generally your sweet spot's between 0.5 and 0.65, sometimes up to 0.8 of an amp. If you're going much over 0.8, you're going to draw a lot of heat into that machine. If you're going over 1 amp, you might run the risk of actually shutting down your power supply and tripping it in this standby mode. Like a lot of criticals will do that. This one has a self-resetting fuse. If you pull too many amps on it, it'll cause it to shut down for a couple hours to protect its circuits inside it. So the next thing this can do, as I was talking about, this meter has no voltage meter on it, or this power supply. So one way we can find that out is if we hook up the positive and negative to the clip cord, it'll give us a voltage reading of what the power supply is putting out. Now this clip cord is hooked up to a power supply with a digital readout. The digital readout on the power supply says 5.9 volts, and you can see here at the clip cord, I'm getting 5.966. So it's kind of guilty of rounding up about half a volt there. But if we test this one for volts, you could in turn count the turns and just write that down so you know 3 turns is 5 volts or 6 turns is 8 volts, and so forth. If you ever get really lost and you don't like just going by the feel of how the machines are operating. Thing with this meter is we can turn it over here to this little triangle button. This is continuity mode. And what that does, it tells us if there's any shorts in our circuit. Obviously we would know because it would be shorted out, but it does give you an audible sign if you do have a proper complete circuit. So if you solder a set of coils together, you could test them just to make sure your soldering job is good enough and that it's actually working. And so we can see that these are good to go. Another thing we can do with the motor, just to test and see if the windings are still good and there's no shorts in the motor, is we can also test it by putting this on the terminals here. Although it can be a little finicky, but as you can see, this motor is still ready to go. It should be. It's brand new. Now say you use this continuity mode to test a machine and you're finding that you're putting the probes on the binders and you're not getting a reading or an audible sound. You know that there's a broken short somewhere between here and the motor. So you would track that up, test the next section and see if you can get that sound, and just test it all the way up to the motor to see exactly where your break is, so you don't have to rip the whole machine apart to resolder it. Again, this would work on the coils as well. So how do we know if a motor is actually burnt out on a rotary machine? The easy way to do that is to test the ohms of the actual motor, just like we did the coils. They're very similar, just a bunch of wire wrapped around in there. We just hook the probes up to the motor. We should get a reading. We're getting around 15 ohms right now. Now most rotary motors can be anywhere between 5 and 30 ohms. If it reads OL like this, it means nothing's connecting and you may have a busted brush or a dead motor. You don't need this tool every day, but when something feels off, this $45 meter can tell you a hell of a lot. And it's a lot cheaper than the alternative, buying a $600 power supply with a built-in readout. Not saying that convenience of having that ready to go at all times while you're tattooing is super handy, but you can always go by feel. Take notes. Hope this helps.